Welcome to note set number 5, solving for x hard. So the reason why it's called hard is because we start adding scary things like multiple steps before we can do the standard solving for x stuff. So this is the really simple version, this first example, where you draw your wall. First you get rid of the thing you're adding or subtracting. So it's a plus 2. To undo that, I minus it away on both sides because I need to keep them equal. I still have this minus 3x, negative 3x, equaling this 2 minus 2 went away to 0, so I don't need to write it. And negative 13 minus 2 is negative 15. Then it's negative 3 times x, because there's nothing between the 3 and the x, which means they're being multiplied. And to undo multiplying, we divide it away on both sides, because we have to keep it equal. And so x is 15 divided by 3 is 5, and a negative divided by a negative is a positive, so x is 5. Remember to check your work. You could do negative 3 times the 5, because it's negative 3x, plus the 2, and when I put it in the calculator, it would give me out negative 13, meaning that my answer is correct. Now there's a lot of things that can make this harder. For example, sometimes you have to combine like terms. You should always combine like terms first before you try to solve for x. So, for this one, on the left side, I see I have 6x's plus 10x's on the left. So I can combine them together and make them 16x's minus 4. Then, on the right, you see there's a minus 2 and plus 11, and those are just number terms. So those could go together as well, giving me negative 2 plus 11 is 9, and then I still have the plus 3x's. Now from here, I can continue to try to solve for x, but I need to get the terms I want on the same side. So I could try to move them all over here. But remember, eventually we want to get x alone. So if I already have some numbers over here, might as well keep them. I'm going to add this 4 over to have it join the 9. So I have 16 x's equals 13 plus 3 x's. These 9 plus 4 is 13. And I bring down my plus 3. Now these 3 x's can go join these x's, but to do that, to flip it over, I have to minus them away. Minus the 13 x's away. I'm out of room, so I'm going to move over here, but 16x minus 13x. Oh, it's a 3x, I'm sorry. Oops. I'm minusing 3x's and I'm minusing 3x's. So 16x minus 3x's is the 13x's. Equaling over here, I have this 13. And the 3x's minus 3x's went away. So now it says 13 times x. 13x is 13. To undo multiplication, I divide both sides by 13. 13 divided by 13 is 1x equals 13 divided by 13 is 1. If I wanted to check my work, everywhere I see an x, I can put a parentheses and plug in 1 and see if they equal each other. For example, 6 times 1 minus 4 plus 10 times 1. If I put that in the calculator, I'd get 6 minus 4 is 2 plus 10 is 12. And does that equal, over here, if I do negative 2 plus 3 times 1 plus 11, well, negative 2 plus 3 is 1 plus 11 is 12. So since my two sides equal, I know that my answer is correct. Sometimes you'll have decimals in your answer. Well, you're allowed to use a calculator. So at the end of the day, don't be afraid of decimals. It's okay that you get decimals in an answer. You can always just plug them back in to check. So if I just start to solve, first I have to minus the 3. So that 4x equals 7. Then I have to divide the 4 away. So that x is 7 divided by 4. Well, you can't easily divide 7 by 4 because it's not a whole number. So if I put 7 divided by 4 into a calculator, I get 1.75. Well, if you get a decimal and you're like, oh no, I think I'm wrong, it's okay to just plug it back in and check. If I did 4 times 1.75 plus 3 in my calculator, I do get out 10, so I am correct. Now sometimes there's decimals in questions. But again, that's okay, because it's just decimals and you have a calculator. So you draw your line. It says minus 0.7. To undo a minus, you add the 0.7. So you just treat it like it's a whole number, but you write what it is, it's a 0.7. And so I still have 1.4 over here. X's. The negative 0.7 plus 0.7 goes away, it cancels, it becomes 0. And if I do 8.2 plus 0.7 in my calculator, I get 8.9. Now, in front of x is a 1.4. So it's being times because there's no plus or minus, so I'm going to divide both sides by 1.4. 1.4. And if I put 8.9 divided by 1.4 into my calculator, I get 6.357. About 3 digits after the dot, after the decimal, is usually good. And again, if you're just worried about it, you could always check your work by doing 1.4 times 6.357 minus 0.7 into the calculator. I'm going to do that real quick. So 1.4 times 6.357 minus 0.7 gives me 8.1998. So it's not exactly 8.2 like the answer is. But when I got my decimal, I didn't write down all the numbers after the points. Which means if I wrote more and typed in more, I'd probably get 8.2. So because it's decimals and because my answer is really, really close to the actual answer, I know I'm right. Go ahead and flip this over for a couple more things that makes this process harder. Come on. So sometimes there could be fractions in questions. We've worked with fractions a lot, but I'm just going to remind you how this works. There's 2 ways you can deal with fractions. The way that I've taught you so far is you draw your line. First you need to add the 2. So then I still have 2/5. X equals negative 6 plus 2 is negative 4. Times both sides by the bottom, which is 5 to get rid of it. 5's cancel, so I'm left with 2 x's equaling negative 4 times 5 is negative 20. Divide both sides by the 2 that's being multiplied to x. So that I get the answer that x is negative 10 because 2 divided by 20 is 10. And a negative divided by a positive is a negative. And that's one way to do it. However, there's another way to do it. And so this is going to take a side note real fast. So there is these fraction rules, and the rules for multiplying fractions are very simple. Let's say you had 3/5 times 2/7. You just go straight across. So on the top in the numerator, you have 3 times 2, which is 6. And on the bottom, you have 5 times 7, and that's in the denominator. So your denominator is 5 times 7, which is 35, and that is your answer. If you're ever asked to divide fractions, there's a rule that says copy, dot, flip. So if you want to do like 3/5 divided by 2/7, that's 7. The rule is you copy the first one. Dot means change this divide to a dot, which is multiply. And then flip the second one. So that turns into 7/2 because you flip it over. And now it's multiplying like above, so you go straight across. So 3 times 7 is 21 for the numerator, and 5 times 2 is 10 for the denominator. And that's how you divide fractions. So another way to think about 2/5 x is 2/5 times x, a fraction times x. So always first, you want to move away the thing that's being added or subtracted on. It's a -2, so I'm going to add my 2 away. So I'm left with my 2/5 x equaling -4. Now instead of timesing by 5 then dividing by 2, you could also just say, well, it's 2/5 times x. And to undo multiplying, I'm going to divide my 2/5 away. So 2/5 divided by 2/5, it's the same on top and bottom, so it's just 1. And then to do -4 divided by 2/5, I do -4 times, because I changed my divide to a dot, copy, dot, and then flip that fraction. Well, 4 isn't a fraction right now, that -4, but it can be, because I can divide any number by 1 to turn it into a fraction, always. So now, I just multiply across the top. -4 times 5 is -20, and so that's my numerator. And my denominator on the bottom is 2 times 1, so that's 2. And -20 divided by +2, a negative divided by a positive is negative, and 20 divided by 2 is 10. So you get the same answer. You just can do it either way. These can also sometimes be difficult if there's parentheses. Remember, parentheses means to distribute through the parentheses or to multiply through the parentheses. So if there's a number in front, you just multiply it into every number in the parentheses. So 3 times 4 is 12, and they're x's, 12x. And then 3 times +1 is +3, and it's going to equal -9. And then you draw your wall, you subtract the 3, you have 12x equaling -12, because -9 minus 3, -9 down 3 is down to -12. Then you divide the 12 that's being multiplied away. 12 divided by 12 is 1x. And then 12 divided by 12 here is just the 1. So x is 1. Remember, for both this one and both of these, you could have plugged the answer back in to check to make sure it was right. Now sometimes these starts to get really hard and they put a bunch of different hard things into the question. So you just got to go in order. Rule 1 is to distribute. If there are parentheses, you need to multiply into them first before you do anything else. So this 4x isn't a part of the parentheses, so I'm just going to write it. But there's a -1/2 in front of this parentheses. So because it's negative and you're multiplying in, a negative times a +10 is negative. 1/2 times 10 just means 10 times 1, which is 10, divided by 2, which is 5. Then I also have to times -1/2 into -8. Well, a negative times a negative becomes a positive. And 1/2 times 8 is, or 1/2 of 8 is 4. And they're x's. Equaling, on the other side, I have a 3 in front of the parentheses, so when I distribute it in, 3 times x is 3x's, because of the invisible 1 in front. And 3 times -4 is -12. Then I have the -10.3 at the end. Step 2 is you always combine like terms only on the same side. Remember that to combine like terms, when there's an equal sign, they have to be on the same side. So, on the left-hand side right now, I have a 4x plus another 4x. They're both x terms. I can put them together and have a total of 8 x's. And then I still have that -5. 4x, 4x, 8 x's minus the 5. Equaling, over here I have 3 x's but no other x terms. And then -12 minus 10.3. Those are both number terms because they're only numbers. So we can combine them together to get -22.3. Now, since my like terms are combined, I do step 3. which is just to continue to solve for x. So you draw your wall. Right now, I have x's on both sides. I like my x's on the left, so I'm going to move these 3 x's over. To move them over, I have to subtract them away, because it's a positive 3 over here. So 8x minus these 3 become 5 x's. Still got minus 5. Equaling, over here the x's went away because I moved them over. 3 minus 3 is 0. But I still have negative 22.3. Now, to continue to solve for x, I need to add this 5 over, because you get rid of the thing being plus or minus first. So I still have 5 x's equaling negative 17.3. And then in the calculator, you divide 17.3 divided by the 5, because it's a 5x. So I'm going to divide both sides by 5 to make the 5 go away from x. So now x is all alone, and it equals 17.3 divided by 5, which is 3.46. However, it was a negative 17.3, and a negative divided by a positive is a negative. So x is negative 3.46. Remember, you could always plug it back into the x's in the problem to check your work to see if we did it right.